We're now going to talk about the order in which elements are processed and the way you can control or not control this ordering. And this is a very interesting topic, and it gets into this issue of how the apply phase is a little different from the split and combine phase in terms of what you can control. So it turns out that the Java Streams framework intentionally allows for variability in the order in which things are processed. That's the apply phase, while it can still be deterministic if you choose in the order in which the results are presented to you. So think to remember, non-deterministic processing order, it's like a roll of the dice. But if you select, you can have deterministic processing results or not, depending on what you want. So let's start talking first by the order in which the chunks that are created by the spliterator are processed. That is done non-deterministically. So it just means that it's up to the underlying infrastructure to decide what to do when you use a parallel stream. Obviously, if you use a sequential stream, then it doesn't matter. The ordering can exhibit different behaviors on different runs, even for the same input. And I'll show you some examples that demonstrate this fact later. And right now, just be aware, just take it on faith that when you submit a bunch of things to run in the common fork join pool, it's up to the common fork join pool and its work stealing algorithm. It's up to the underlying operating system kernel and its scheduling discipline. It's up to the underlying multi-core processors to decide when and how things run. You have little control over this. Just deal with it. It's not a bad thing. Why this is done, of course, is because non-determinism enables optimizations to be performed at multiple layers by parts of the system that have deeper insights into what's going on than you might have as a programmer. Because the underlying system, we'll take a look at the fork join pool, for example, it knows internally which of its decks are longer than others. And so when a worker thread in the fork join pool runs out of stuff to do, it can simply look around and randomly pick somebody else's deck to steal from, and that's perfectly fine. It makes the system have greater processor utilization, and it doesn't really affect the outcome other than the fact things ran in different orders. And the same kind of optimizations take place at many other layers in the software and hardware stack. So this example for work stealing, as I said, is a non-deterministic optimization. It depends on random behavior. In fact, the fork join pool inherently uses randomness when it goes to decide which of the decks to steal from at the next opportunity. So that's just a quick overview of the processing order. We will talk in more detail with some examples here to make it more interesting.